Here we go. This is page 3 on the unit 7 test review. Question number 11. All right, there's two ways that, just looking at this off the top of my head, there's two ways that I can think to do this problem. We'll start with the more difficult way first, because that way you won't appreciate the easy way. Let's call this A. That's A for the altitude, whatever. I can figure out A. I can't go straight to X if I'm going to, go this route. So I'm going to say the sine of A, sine of angle A, I'm sorry, the sine of 52 degrees, sine of 52 degrees equals the opposite, which is A over 9. All right, so A equals 9 times the sine of 52. I'm just going to type that in the calculator real quick. 9 times the sine of 52. What does that give us? 7. We'll call it 7.09. 7.09. All right. From here, now we can say the sine of 35. The sine of 35 equals A over X. All right, but we know what A is, right? That was at 7.09. 7.09. All right, so we solve this, we're going to get X equals 7.09 divided by the sine of 35 this time. All right, so this is kind of like a two-step problem. So let's just type that in again, 7.09 divided by the sine of 35 here. Sine of 35, and that gives us 12.36. 12.36. So what we did on this one is we focused in on this smaller triangle, and that got us, A, and then we used A along with this triangle on the right side to help us find X. All right, that was option number 1. So I guess, kind of going in the same process, we can figure out why doing this. So instead, let's say the cosine now. The cosine, I'm going to call this B. I'm going to say the cosine of 52. Cosine of 52 equals the adjacent, so B over 9. All right, so therefore, B equals 9 times the cosine of 52. 9 times the cosine of 52, that gives us 5.54. 5.54. Okay, and then I'm going to call this one over here C. And what I'm going to do now is I'm going to say the cosine of 35. Cosine of 35 equals the adjacent this time. So it's C divided by the hypotenuse. Well, we found the hypotenuse. The hypotenuse was 12.36. All right, so multiply both sides over by that 12.36. What we're going to have is 12.36 times the cosine of 35. That's going to be our second answer, 10.12. So 10.12. All right, so what we're going to do is just add those two numbers together. Red and blue make purple, so that is going to give us 15.68, right? We're just adding that whole thing together to get us Y. All right, so keep in mind, that was kind of the hard way to do this. What's up? Yeah, of course. I'm just making a video. All right, so that was way number 1 of solving this problem. So let's do it a little bit differently. Keep in mind, every single one of these answers, we rounded just a little bit. So we rounded A, 7.09. We rounded X at 12.36, and then 15.60. It's all going to be just a little bit different. But if we do it the easier way, we're going to get a little bit more accurate of an answer. So let's just look at this big old triangle. All right, that blue one. If we completely ignore this line on the inside, let's just get rid of it. Let's just pretend it's not there. We're allowed to do that. That's fine. What we're going to have is a law of sines kind of situation. All right, so we could say the sine of 52 degrees, sine of 52 degrees over X is going to be equal to the sine of 35 degrees over 9. Right? We know how to solve that. Just use the law of sines. That's going to be, let's see, cross multiply and divide over. We're going to have x equals 9 times the sine of 52 divided by the sine of 35. And then we type that all into our calculator. That's going to give us 9 times the sine of 52 divided by the sine of 35. And so we got a 12.36, which is pretty close to what we got last time. So let's do something similar for y now. So use the triangle sum theorem. We know all three sides of the triangle add up to 180 degrees. We got 180 minus 52 minus 35. So leaves 93 degrees. So this angle up here is 93. All right, so using the law of sines again to find y. Let's just use the 35 on that. So we can say the sine 35 degrees over 9 equals the sine 93 degrees over y. All right, same process. Cross multiply and divide. So we're going to get 9 times the sine of 93 divided by the sine 35. Type that all in. Let's see what we. And that gives us 15.66. I'm pretty sure that was pretty close to what we got last time. Don't remember. We're going to have to go back up here. I don't remember, but that should be pretty close. All right, so that was two ways of doing problem number 11. Problem number 12, equilateral triangle. Draw a picture, right? What does equilateral mean? That means it's the same on all three sides. So it has a perimeter of 20. That means all three sides add up to 124. So we know each one of these sides is 8. All right. So find the altitude of the triangle. Remember, the altitude starts at a vertex and it goes straight down. It's going to make a 90-degree angle. One piece of useful information on an equilateral triangle is that all three sides add up to 100, so they're all congruent, so they're all 60. So let's focus in on this triangle right here. Right, what we get is a 30, 60, 90 triangle. And if you remember from your 30, 60, 90 triangle facts, we know what's opposite of the 30 degree is always half of the hypotenuse. Well, the hypotenuse in this blue triangle is 8, so that means our short side, the one across from 30, is just 4. 8. What we're going to do from there is we're going to take the 4 and multiply it by the square root of 3, so we know the long side, or the altitude in this equilateral triangle is 4 times the square root of 3. All right, so you might want to review your 30, 60, 90 rules on that one. All right, next one is square. Square has a diagonal of length 12. Find the perimeter and the area. So keep in mind, let's just focus in on this piece right here. All right, it's a square, so it's 90 degrees, and all sides are the same. So what we actually have here is, it turns out this is an isosceles right triangle, or in other words, a 45, 45, 90 triangle with a hypotenuse of length 12. To go from the hypotenuse to the leg, the isosceles right triangle, that 45, 45, 90 triangle, divide the hypotenuse by the square root of 2, and then rationalize. So by the top and the bottom by square root of 2, we have 12 root 2 over a regular 2, which simplifies down to 6 times the square root of 2. All right, so again, the perimeter, add up all 4 sides. So we know each side 6 square root of 2. So, or you just do 6 root 2 times 4. So the perimeter equals 24 times the square root of 2. Area of a square, that's just base times height. So what we're going to have is 6 square root of 2 times 6 square root of 2. Now, the multiplication rules are a little bit different than the addition rules for radicals. So the 6 times 6, we do just normally, and that's 36. And then square root of 2 times the square root of 2 is the square root of 4. Right? Well, the square root of 4 is 2. So 36 times 2, 36 times a regular 2 equals 72. All right, so if you use trig on this one, you're going to get some decimal. Right? You're going to get like 72.25. So sometimes it's easier to call back on those 30, 60, 90, 45, 45, 90 rules to get nice whole answers. Because when we do trig, we end up rounding at some point. But when we do this radical form, we don't have to round anything. All right, so let's see. I think this is the last, all right, last one, 14. Triangle ABC. All right, so here's triangle A, B, C. We know C is a right angle. Now, if the sine of A is 3/7, keep in mind sine goes with the opposite and the hypotenuse. All right, so if we're looking at angle A, the opposite side is 3. All right, the hypotenuse ends up being 7. So what they want is they want the tangent of B. So what we need to do is we need to find the third side. All right. Now, before we even learned trig, all right, if we had two sides of a triangle, a right triangle, we could find the third using the Pythagorean theorem. All right, so we have a squared plus b squared equals c squared. So just plug in what you know. So we have 3 squared plus b squared equals 7 squared. So we know b squared equals 40. 49 minus 9 is 40. And then you square root it. So we have b equals the square root of 40. And then let's break down our square roots. So we have square root of 4 times the square root of 10, which equals 2 times the square root of 10. All right. So the tangent of angle B, right? So we know x equals 2 times the square root of 10. So the tangent of angle B is the opposite, so 2 root 10 over the adjacent, which is 3. Right? And this would be our answer for 14, part A. Now, part B wants us to find the measures of all 3 angles. All right. Well, luckily, we know one of them is 90, so that one's, right, so angle C equals 90. Right. So again, let's not make it more complicated than what we need to, or whatever. Let's just do this. We know 3 is the adjacent, 7 is the hypotenuse. Let's take the inverse cosine. So we know the cosine of angle B equals 3/7. Right. Therefore, the inverse cosine of 3/7 equals angle B. Right. So type that in your calculator. It's all calculated from here. The inverse cosine of 3/7 equals, we're going to round that up, so we're going to say 65 degrees. Remember, we're going to round to the nearest whole degree, so 65 degrees. All right, now don't overcomplicate how to find A. We know C was 90, B is 65, so let's just do the triangle sum. So 180 minus 90 minus 65 equals 25. All right, so angle A equals 25 degrees. So that, I'm pretty sure that was the last one on page 3. All right, so this page was all about your 30, 60, 90, reviewing all of that stuff, your SOHCAHTOA, the early trig stuff. So I think there are 2 questions like that on your test. All right, so that was page 3. Next video will be page 4.